You type 3 words, "See you at 7, and press send. A second passes. 2 small ticks appear beside the message. You put your phone down and move on with your day. That second is what this is about. Not the message, and not the relationship it belongs to. The second itself, and everything that happened inside it before those ticks could appear. The message reaching its destination was not a single action. It was a sequence of coordinated steps, each building on the last, each depending on mechanisms designed specifically for the ways networks fail. The ticks do not represent one thing going right. They represent many things going right, in a precise order, fast enough that you never had to notice any of them. This is what that second contained. Before a single byte of your message moved, TCP asked a question. Is there already an open connection to the server that handles your messages? Connections are not free. Opening one requires both sides to commit before any data flows, an exchange of signals where each end says, "I am here, I am ready, and I agree to the terms of what is about to happen." If a connection was already open from a recent exchange, your message could use it immediately. If not, the handshake happened first, adding its own round trip to the second, while both sides confirmed they were ready. Only once that contract was in place did your content begin to move. 3 words, 2 sides, 1 agreement. TCP took your message and handed it to the network. The network carrying it is best effort. The routers that forwarded your packets did not know what they contained, did not care whether they arrived, and would not report it if they were dropped. Each router read the destination address and passed the packet toward it. That is the complete extent of the network's commitment. TCP knew this before it sent anything. Before your message left your device, a copy of it was held in memory. Every byte that had gone out but not yet been confirmed, sitting in reserve, waiting. The amount of data allowed to be outstanding at any moment is bounded by the window, which determines how much can be in flight without a reply. For 3 words, the window was more than sufficient. The message moved, the routers forwarded it. The network kept no record of any of it. Your message arrived at the server, at the OS buffer to be precise, where it waited for the application to collect it. The server's TCP layer sent an acknowledgement back toward your device. Received up to this point, continue from here. That signal made the same journey in reverse, across the same best effort network, consuming a small portion of the reverse bandwidth that reliable delivery always requires. When the acknowledgement reached your device, TCP released its hold on the confirmed bytes. The copy held in memory was no longer needed. The obligation the sender had been carrying since the moment the message left was discharged. The window advanced. That acknowledgement was not the double tick. What it confirmed was that the bytes had arrived at the server's machine, specifically at the OS buffer. What the application did with them from there was outside TCP's scope entirely. The messaging software running on the server had to read the bytes from that buffer, pass them, store the message, and generate its own confirmation, an application-level signal saying, received, processed, delivered. That is what the 2 ticks represent, not TCP's guarantee, the application's. TCP's job was already complete before the ticks existed. The application chose TCP for this exchange, and the choice was deliberate. A text message has to arrive complete. 3 words delivered as 2 is not a partial success, it is a failure. The cost that reliability carries, the acknowledgement traffic returning against the flow of data, the window constraining how much could be outstanding, the round-trip time setting the floor on how fast the exchange could complete, was the correct price for a message that had to arrive exactly right. A voice call would have made the other choice. Audio that arrives a second late is worse than audio with a brief gap. That application accepts the losses and keeps moving. Both options exist for a reason. Choosing between them is the application's decision, made according to what completeness is worth, relative to what timeliness costs. While your message was crossing the network, a set of mechanisms was standing by that your exchange never needed. If a packet had gone missing, a timer would have fired. A retransmission would have carried the data again. If that retransmission also produced no reply, the timeout would have grown, the sender backing off, giving the network room, waiting longer before trying again. The window would have contracted. Then, cautiously, TCP would have probed for available capacity, doubling from a low base until it found the level at which things were working again, and expanding slowly from there. If the network had been under stress, congested across many simultaneous connections, retransmissions adding to the load that was causing the losses, the recovery would have taken longer. Multiple connections backing off, finding their footing again, probing in parallel, each one trying not to recreate the conditions that caused the problem. None of that happened. The path was clean. Acknowledgements returned promptly. The window held open. The message cleared in a fraction of the second you gave it, and everything built to handle the worst case sat unused, patient, ready for the next exchange. That is what the double tick cost. Not in time, the whole thing completed in under a second. Not in compute, the devices involved barely registered it. But in structure, a contract established before the first byte moved, a tracking system that held the message in reserve until its arrival was confirmed, a fallback mechanism ready to fire the moment silence exceeded its threshold, a recovery process waiting behind that, a precise understanding of where the network's obligation ended and the application's began, and a deliberate choice about what kind of guarantee the data deserved. Each of those pieces was designed to solve a specific problem. The contract solves the problem of two strangers on an unreliable network needing to trust each other. The tracking system solves the problem of a sender that cannot see what the network drops. The acknowledgement solves the problem of confirming receipt without asking. The retransmission solves the problem of packets that never come back. The recovery solves the problem of a network that needs space to heal. The application layer solves the problem of meaning, which the transport layer was never equipped to handle. They are not independent features. They are a system, each one enabling the next, each one covering the gap that the one below it left open. The speed is real, so is the reliability. What neither of those words captures is the coordination, the number of things that had to work together, invisibly, for an exchange to feel as effortless as typing 3 words, pressing send, and watching 2 ticks appear. That is how it works, all of it, every time.